So let's look at when we would not choose the mean. In fact, we would choose the median over the mean. And it has to do with the presence of outliers. And we've already talked a little bit about outliers. We said that they are the numbers that stick out because they're very different from all the other numbers in the data set. So using the analogy of sheep, they would be the black sheep, right? So the black sheep stick out because they're very different from all the other sheep, which I've learned, one thing I've learned since moving to Utah from Quebec, Canada, where we don't have a lot of sheep, is that sheep are very seldom white, and they're also very smelly. I much prefer the black sheep. Anyways, that's kind of neither here nor there, but just so you know that a number is considered an outlier in much the way a black sheep would be considered the outlier. All right, so another way of thinking about it is that outliers here, typically when we see outliers, they tend to be out in the tails of a distribution. So assuming that you've got that kind of bell-shaped curve, the outliers would be in the tails. Now, we said that the median is not a very sensitive average. And because it's not very sensitive, it actually makes it the preferred average to use when we have outliers present in one direction only. So remember I said that if we have that nice kind of normal shape, so if you follow my cursor here, I'm trying to draw a normal distribution, right? In that case, we have outliers in both directions because we have one in this tail and one in that tail. But the median is only the preferred average to use when you have outliers in one direction. And don't worry, I'm going to explain why that's the case and why being insensitive makes the median a better choice for the skewed distribution. So let's consider a data set. So if you have the data set 2, 4, 5, 8, 10, 13, 14, and then 288, well, 288 you should identify as being the outlier, right? And we would say that this is an outlier in one direction because we don't have an outlier over at this end that is similarly dissimilar. So we don't have like a minus 200 or something very, very different at this end. So we only have an outlier here. Now, if we were to calculate the mean, remember the mean is super sensitive, right? It is extremely sensitive because it looks at every single number in terms of its calculation. So you would add up all these numbers and divide by however many numbers we have, and that would give you a mean equal to 43. Now, if we look at this data set here, would you really think that 43 is a typical or representative number? Most people wouldn't. They would look at this and say, well, 43, no, it's really, I mean, except for this one outlier, we really should find a typical or representative number in this range, right? The 288 is having too strong an influence on the calculation of the mean. Now, if we chose the median, then the median is simply the middle number, right? So we have to order these numbers from lowest to highest, which I've already done. And the median in this case needs to be the average of the two middle numbers. If we chose 8, that wouldn't work because we have 3 below and 4 above. And if we choose 10, that won't work as the median because we have 4 below and 3 above. So that means we have to pick the two middle numbers and then take the mean of these two. So in this case, it's 9. So 9 is our median. Now, if you ask yourself which one is more representative of this data set, I think most of us would agree that 9 seems more representative, right? And the mode wouldn't help us here because there is no mode. Each number appears only once. So we'd have to report no mode, doesn't help us. So here the median would be the better choice. All right. Now, the median is, remember, is insensitive. The median doesn't care about what the numbers actually equal. It's only, in a way, it only cares about an address and the number that lives at that address. So the address is the middle number, right? Who lives in that middle position, at that middle house? And then if it happens to be 8 or 10, or in this case, 9, which actually isn't even in our data set, well, then that's the only thing that matters. It doesn't care that this is a 2 and this is a 4, that this is a 288. It couldn't care less. It only wants to know who lives at that middle address. All right, so in this case, the median would be the best or most representative number from the data set. All right, so here's another way to look at it. So when we have outliers in one direction, essentially we have a skewed data set like this. All right, this would be the most common type of situation where you have outliers in one direction. Right? And positive skew, negative skew, I don't know that one occurs more often than the other. All I can say is that when we have an outlier, usually it's in a tail. Okay, if we were to give, let's blend these two distributions together. Okay, so I just want to pretend that they're merging, so they're one distribution. So what you have is a whole whack of scores here, and then it drops down to almost nothing here, and then a whole whack of scores on this side. Then we could argue that scores right here are the outliers, right? But generally, we don't see too many of these distributions where we have a lot of really, really small numbers, a lot of really, really large numbers, and anything in between would be very uncommon. But if we did see a distribution like that, then the outliers would be here in the middle. All right, so let's go back to positive and negative skews, which occur very often. In a positive skew, your outliers are here in this tail, the positive tail. If you have a negative skew, your outliers are here in the negative tail, right, where the negative side of the distribution is. Now, if we let A, B, and C stand for mode, median, and mean, which of these should we choose for our average? Okay, so A is mode, B is median, C is mean. Which one should we choose? Well, we first have to figure out approximately where each one would be located. So if we're talking about a positive skew, finding the mode is the easiest because we just have to find the peak frequency. Remember that this line represents frequency. So we get to the peak and we draw a straight line underneath it, and then whatever score is here in the A position, that would be our mode. All right. Now, B is the median. So to locate B, well, we have to kind of guesstimate. We want to divide the entire area. So if we were to shade in this whole distribution here, we want to divide the area in half. So if I put a line here, what I'm basically saying is that if I were to shade in everything to the left of the line and calculated the area, that would be approximately equal to the shaded area to the right of this line. Okay, so we're dividing the distribution in half, but we're dividing the entire area in half. So you have to think in terms of areas now. So it's a guesstimate, but we're saying B is going to be about here. B is the median. And then C is the mean. And C, unlike the median and the mode, which are very insensitive, C is sensitive. C is the mean. It's very sensitive. So if you have a very large or a couple of very large numbers here, what they are going to do is they're going to pull C towards them. All right, just like we saw in the previous slide where we had 288 was unlike any of the other numbers, which were pretty small. And what effect did it have on the mean? Well, it increased the mean to 43. In other words, it pulled the mean towards it. So you're always going to get this order in a positively skewed distribution. you're going to see the mode here, the most frequent score, the median, which is cutting the area of the distribution in half, and then you're going to find the mean, and the mean is going to be the one most influenced by these outliers, so it's going to be the average that is pulled towards the outliers. It's going to increase this number more than anything else. All right? So it's kind of like which one now should we choose? It's kind of like Goldilocks. The mode, this one is too low, and the mean, this one is too high. But B, the median, is just right. Okay, so the median in a way is kind of like the compromise. Okay, now if your skew was negative, well, you just have to kind of flip this over. So instead of having ABC, now it's CBA. But you shouldn't have to memorize that. You should be able to look at this and just use the logic. Remember, A is the mode. Find the peak frequency, draw a line under it. That's the most frequent score. So that's where the mode is. The median is where you have to kind of guesstimate, but you want to draw, if this is shaded in, you want to make sure that this shaded area to the right of the line is the same as this shaded area to the left of the line. And that would put the median right about here. Okay, and again, I'm kind of guesstimating. And then the mean, well, remember the mean is the most sensitive average, and it is going to be drawn towards the outliers. So the mean is going to be the average closest to the outliers. All right? Now, knowing this, how your distribution is shaped, is really important, because if you were to not look at the shape of your distribution and you report using the mean, if it's positively skewed, then you're going to exaggerate. You're going to say that the average is higher than really what a typical score is. Similarly, if you have a negatively skewed distribution and you report the mean, then you're underestimating what the average is for the data set. All right? Now, you might think this has no real-world applications, but if you read the book, my book, you'll see that there is. Faculty often get evaluated according to some sort of point system, and maybe there's a question on the evaluation that asks about their teaching effectiveness. And most students, well, I should say most faculty, get evaluated like this. So in other words, most of the students evaluate the faculty member pretty high. But then there's always some students who, for whatever reason, thought that this was the worst faculty member ever, and they may rate the faculty member very, very low. Well, without looking at the shape of the distribution, if we only look at the mean score for the faculty member, we're going to perhaps be misled into thinking that they're not a very effective teacher. But in reality, most of the students thought that professor was doing a really good job. And so if institutions are making hiring and firing decisions based on the mean effectiveness, that's going to bias a lot of faculty towards lower evaluations. At least on the surface, we're going to think they're getting low evaluations, and maybe that's going to cost them their jobs, where in reality they were doing a pretty darn good job. Okay, so it is important to be able to understand how we actually use statistics and how sometimes we can come to false conclusions if we're not using the right one. All right, let's look at outliers and the median when we have outliers in both directions. So if our data follows this basic shape, doesn't have to be perfect, but if it follows the basic shape, so it's normally distributed, we have outliers in this direction, so the negative tail, and we have outliers in this direction, so the positive tail. So if it more or less follows this basic shape, and as long as it's not too far off from this, essentially these outliers here are going to try and pull the mean towards them, right? Like a tug of war. So here's the negative tail. What's this guy doing? He's trying to pull the mean towards him. What about over on this side? Okay, this is the positive tail, and this guy here, he represents the positive tail, and what is he doing? He's trying to pull the mean towards it. But if we've got a relatively normal distribution, these two guys are going to be evenly matched. They're going to exert the same amount of force on the mean as this guy. Okay, so who wins the tug of war if you're evenly matched in all ways, in every shape and form? If you're evenly matched, I suppose you're going to be exhausted at the same time, and no one wins, right? Essentially what happens is these outliers cancel out these outliers, all right? And if that's the case, then the mean is going to stay in the middle. So will the mode, and in fact, the median, and even the mode. All right, they're not, well, the median and the mode are not going to be affected by outliers anyways, right? Remember, the median and the mode are very insensitive. But in a case like this, the mean is going to be in the middle as well. So which one should you choose? The mean. So having outliers doesn't necessarily automatically mean that you should choose the median. You have to look at the way your distribution is shaped. And if it's approximately normally distributed, then outliers cancel each other out in terms of the influence on the mean, and you use the mean. But if you have outliers in one direction, use the median. Okay? All right. That is it for Chapter 3. So you can choose to move on to Chapter 4 now, or you can take a break